Okay, I've started the recording. Hope you have all installed Hadoop in your machine, in your lab. Okay, is this up and running? I hope at least a single node should be there up and running. Then only you can do MapReduce. We'll have a question in MapReduce. Okay, and whoever is facing problems, it is good that if you connect to the class and see it, because uh, many things we cannot resolve it afterwards by screenshot or thing, other things. If you connect through the to the class, then during installation times, at least configuration times, we can easily resolve it. Okay, so the last class we had last few classes we had written a map reduce program to find the number of words in a document. Okay, we will write two more programs where we can work on some vaccination, COVID vaccination data, and another code, how do we input multiple files and see it. Those two we will do. Before that, we will understand in depth about how MapReduce works. Okay, so I will share my screen. So a little revision about the map reduce. This we have seen, like all the data which we are going to store, which is going to be stored in the HDFS. And we also know like Hadoop comes with the two components, like initial component, the necessary components like the storage and the processing unit. Processing unit one we are seeing is the map reducing unit, and we can also have other applications like Pig, Hive, or HBase is again a database, or Apache Spark. Apache Spark can also work independent of the Hadoop framework, but you can also put on top of Hadoop framework and use the HDFS, which is the storage unit, to work on Apache Hadoop and other applications which will run on as a processing unit. Okay, whereas HDFS and HBase, uh, Cassandra, or all will be the storage units that you can use it. Okay, so when we store the data, we store into our HDFS. We know the commands using put, we will store into our HDFS, and that based on the file format, there is something like input file formats. Each will have, if it is a text data, they will be having a text input file format. If it is a sequence file data, sequence file means without any division or a sequence of a files or stream of a files, or like images or any clips, those kind of input data you are getting it, that will be split based on the sequence file format. And there are different types that I will show it after a while. Okay, and those files files or their data will be split first. Those are called the input splits. Okay, that splits means, say for example, if I am talking about a text file, if you have 10 lines of a code, uh, this 10 lines, like two lines will be split together, or the first line will be split. Okay, and this will form as an one input split. Okay, second line will be split, third line will be split, and each will go to one map task. Okay, each will start a map task means that processing which we are going to do on the line, the processing which we are going to do on the line, right? Like we are going to divide the words in the line, okay, and add a one to it. Likewise, it will be working. That is what first the data is splitted. Okay, those are called the input splits. The input splits is done based on the input format types. Okay, if it is a text format type, then each line will be split into a single input split. Or if it is a sequence format, it will be based on the sequence, because that class, it's the text input file format class, will have the definition like how to divide the file if it is a text file. Likewise, then from the input splits, it goes to the record reader. The record reader, what it will do, converts this input splits, okay, into a key value pairs. So the from here only we will start our code, our programmer code, which is a map phase which we have written, no, map method. I think I can use a pen now. Map method which we have used, it has started from this place only. Okay, before this, whatever is happening over here will be taken care, and whatever is happening here are all taken care by the framework itself. Okay, framework itself, and the split also happens based on whatever the file data we are going to process it. Okay, so the input to the map, method or the map function which we write itself is a key value pair, that it is coming from the record reader. Okay, record reader, there it is a like a inbuilt service process we can say, which will be running inside your Hadoop environment. Okay, and this, see, whatever the input splits, that is key value pairs which we are getting it, that will go to the map. Okay, map will generate our the intermediate key value pairs. Say for example, we had a document like a car, truck, and car, again a train. Likewise, say for example, this is a one uh, line in a document. Okay, this one, how the intermediate results will be prepared over here is car has occurred once. Okay, if it is a word count example we are writing, we will be writing the code in such a way that if we wanted to divide each of the uh, word into separate. Okay, car comma one and truck had occurred for once. This is the intermediate results. Again, car has occurred once and train has occurred once. Likewise. Okay, this intermediate results, this is the intermediate key value pair. Here the key is the car and the value is 1. Okay, this is how we will append it in our code. Then afterwards there is a phase like a partitioner. Okay, this phase, what it will do, this service process, what it will do, it will decide how many number of reduce task is needed. Okay, I'll again tell you what is map task and reduce task. How many reducers are needed to aggregate all these results? See, mapping phase is the transformation phase. Okay, transformation means converting your data, that is the input key value pairs, in which is passed to your code into an intermediate results. Okay, by adding one to them, and the reducer is the aggregation phase. Okay, so how many reducers are needed from the for this mapped result? Okay, intermediate results, so that will be decided by the partitioner. Okay, after partitioning, it will go for this shuffling and sorting phase. Shuffling and sorting phase, how it will happen is, say for example, you have 10 lines of text. Okay, in your input document you have 10 lines, 1 2 3 4 5, and 10 more lines are there. Okay, 5 lines, and this is divided into 128 bytes. Say for example, first 5 lines are fitting into 128 bytes. Okay, and this, if the Hadoop framework is putting in node 1, okay, first 5 lines, and the next 5 lines are put into another node 2. Okay, so here it will give an intermediate. It means car, truck, all these 5 lines are here, and another set of a car, truck, and car, bus, another 5 lines of text is in this node 2. Okay, so it means you have to aggregate all these results from all the nodes, right? Then only you will get the actual data. Okay, that is what the programming of Hadoop, it means. It divides your data, and the processing happens in this node also, and the processing will happen in this node also parallelly, and you will aggregate it means you need the result from this one, right, and also from this node. So that's what this place, this is and sorting shuffling and sorting will do. What it will do, takes the intermediate key value pairs exchanged by the all nodes, and it will try to aggregate and give a final results. Okay, so that aggregation is happening in the reduce phase. Okay, after sorting, what it will do, it will create a list. Okay, kind of list, car comma 1. Okay, then car comma 1. Okay, this is one list. Okay, because this the key of this, the car is, the key of this list is a car. Another list it will create like a truck. Okay, there is only one truck in this line, and another result it will create as a train. Okay, so all these things in the reduce function, what we will do, we will do a sum of key and values. So car will become 2, and truck will become 2. Sorry, 1, and train will become 1. Likewise, we also take the the intermediate key value pair from the second node also, and aggregate it together and give the final results. The final result will again be stored into the HDFS itself. Okay, this is the flow, MapReduce flow. In this MapReduce flow, what all the processes or the services involved is, first the input splits happens. The data which we are sending, the data set which we are storing, that will be splitted. Okay, splitted into multiple lines of 128 megabytes. Okay, each megabytes will start a map task. That's why you see multiple map tasks here. Okay, the input split data, here it will be like an input split data. This input split data uh, will be read by the record reader. Okay, record reader input split data is nothing but the 128 bytes. That record reader will generate the key value pairs. That I will tell you how this, the one which is here it is creating, no, the key value pairs are arriving, that I will show you now. Okay, then afterwards we will goes to the mapper phase, mapper method, where it will do our map tasks, that is a dividing of our complete text into different words. Okay, that we will write the logic for this. And sorting and shuffling happens. Actually partitioner I should put it here. Okay, partitioner, it will uh, these these things are part of reducer phases. Okay, reducer phase. This we will write only the class for the reduce method. We will use the class for the reduce method, but all these things will use the reduce method class itself, and we can define it. Okay, shuffling, sorting and practitioner is all internally by the Hadoop framework itself. Combiner is, we can call it as a mini reducer. Okay, it is like an optimizer. It is an optional service. We can mention it in our main program. See, if you we see our main program, there we will mention our classes for the reduce class, job.reduce class, and job for dot mapper class. There itself you can mention about the combiner class, which is like a, before going to the actual reduce, this will do a optimal reduce. Okay, that I will tell you how it is all happening. Okay, till now is it okay? I will tell you more further on. See, input splits, how it happens. Say for example, if you think this as a document which I'm sample document, okay, which I'm going to store into the HDFS, and I wanted to do a split. I wanted to find word count on that. Word count on that means our output we need is on has occurred once, right? And the has occurred once, two, three, three times. Okay, our final output will be the has occurred when you the has occurred three times, and off has occurred twice. Half has occurred twice. So this is going to be our final output. You can imagine like you are going to store this part of a document, a sample document in your HDFS, and you are going to write a map reducer function to find the number of times a particular word has occurred. Okay, that is your problem statement. You can think of like that. So before we write into our map method, I say that the input to the map method itself is the key value pair. This key value pair is generated based on the input format types. Okay, input format types. Input format types means these are text document. So it will take the input format type as a text format, text input format. Okay, there are various types of input format, and this text format, what it will do is it will generate the input splits. How it will generate is it will read the document. Okay, the framework itself will read the document, and it will divide the document into 128 megabyte chunks. Okay, so wherever it is ending with 128 megabyte chunks, it will read it and it will take the offset. The key value pair, how it is generated is with offset. Okay, this is keep on coming with offset comma the line itself. Okay, just a moment. Offset comma line itself. offset comma line itself. Offset means it will count the line. Okay, if it is taking the first line as the is if it is going to divide each line into input split, it will read it say 0 1 2 3 4. Space will also be counted. Okay, 3 4 5 6 7 8 9 10. Likewise it will keep counting the number of characters occurred in the first line. So the offset for the first line is 0 because it is not having any words in the front. The offset for the second line is, see, this will have a 33 characters. Okay, sorry, 32 characters. The second line is starting from 33. So the key for the second input split, this is the first input split 1, and this is the second input split. Okay, so this is going to start from 3. Then if you count all the characters here, space will also be counted. It might be ending it with a comma with 56. So the third input split will be starting from 57. Sorry, 57. Okay, B is gonna start from the character number 57 and the whole line. Okay, this is the key and this is the value. Okay, that is how the input split happens. What it is doing, each line, the offset and the offset will be the key, and the line itself is going to be the value. Okay, this is what we will pass it to our map function, which we are going to write it. Okay, that it will generate the intermediate key value results, which is nothing but on has occurred for once, d has occurred for, in this input split it has occurred for once. Okay, and top has occurred for once. Okay, D has occurred for twice, and Crumpetty has occurred for once. Tree has occurred for once. Likewise, it will do it. Each input split will start a map reduce task. Okay, map is not map reduce task, map task. This is the mapping phase. In the map task, we have written our code no to divide this word. On has occurred once, d has occurred once, and sorry, yeah, once. This also occurred once, top has occurred once. All this will happen in this map task for the first line. Second input split will start the another map task. Okay, so likewise it will divide the line into different words. Okay, based on the string tokenizer, we have a string tokenizer class, right? With that it will divide it, and it will add 1 1 to it. This is what this input split happens. After the input split, it will go to our map task and it will do all other functionalities. Okay, did you understand how the input split happens? And you have to understand that to the map function which we are writing, the input to the map function itself is a key value pair that is generated by the Hadoop framework itself, and those are called the input splits. Okay, how the input splits are generated is by the key value pair, which is nothing but offset comma line. Offset is nothing but the uh, where that line is going to start. Okay, that character number. Okay, the first line is going to start from 0, the second line is going to start from 33, third line is going to start from 57, and fourth line is going to start from 89. Okay, so there will be mm, this many, like a 0 comma the line itself. Okay, and 33 comma the line, 57, sorry, 57 comma the line, and 89 comma the line. These many input splits are generated. Okay, this is generated by the framework itself, and for this each input split, one map task will start. That task will do the whatever we are writing in the code, right? Uh, that work this task will do, this map task will do it. Okay, once this is a generator, it will go to the shuffling phase and all those things. Okay, here we will have the outputs like on has occurred once and the has occurred once. Likewise, no, all these things will be aggregated in the reduce method. Okay, in our reduce method we will aggregate it and we will give the final results. Till now, is it okay? Are you able to follow? Normally we will not touch upon all this input splits type, okay, because we will not, this is taken care by framework itself, no. So we can mention like how to set the input splits, okay, how the bytes how much, how the data should be divided, okay. This configuration you can change it in your map reduce file, okay, .xml file. And the splits, how many splits you wanted, okay, that it is, there are many types in the splits, okay. One I have told as a text input format, there is another like n line input format. In the n line input format type, what it will do is, we can specify the number of lines you wanted to make it as a one input split. Here we are considering first line, second line as a one input split, right. In n line format you can specify, take two lines as a one input split. So 0 33, these together will be considered as one input split, okay. And that map task will be running for that two lines. Likewise you can mention it. So what is the input format? It is nothing but based on your data. See, we have strings, no, in Java we have a string, a data type we say that it is a string data type, a phone number we say it is a string data type, an integer type we have it, right, data type. Likewise here in Hadoop it is a complete data you are going to talk about, you are not going to talk about individual characters or all stuffs. It is like a bulk of data it is going to come, right, or the streaming data or a sequence data it is going to come for processing. There you cannot segregate the data or go to a minimal level and say that this is an integer, this is an a string, right, that you cannot say it. So for the complete data set itself they will call it in the form of the text input format, okay. This is of type text input format. And another is of type XML input format, okay. XML input format means, you remember, right, we are configuring, we are editing the configuration files, those files are XML files, okay. If the data is in the form of XML files, then XML input format class will have the logic to handle those kind of data. Likewise, it means the XML input text format file will tell how you have to divide the XML files. Okay. However, we are dividing the text input format into each line of 128 megabytes and making it as a key value pair, right. That one, each text sorry, each input formats will specify how you have to split your input data. That's just what about input splits. Till now is it okay? I will move on. If I'm going fast also let me know. Yeah, I'll move on then. Okay. Okay, so this is the kind of a weather data. Okay, you can imagine that the data will be like this, but this data you can say it a little semi-structure also you can say it. Okay, this data if you can see, you can it is following a certain format, right? It like after three dots something is there, n9 is always there in that, and after plus some data is there, okay, after plus some more data is there. So this is a kind of a sample weather data, okay, that is taken for processing. This data, this is an example which is available in that book, the Hadoop the definitive guide book. Okay, I have taken this example from that only. Here they say like that they are going to find out the temperature, okay, this they will call it as a temperature. Here they are mentioning, if you can see it, in the each year, what is the temperature for the each year, and also they can find out what is the maximum temperature arrived in this certain set of data. Okay, this is the data, raw data which we have received. Okay, we are going to do a part of analysis like how the data is looking like. This is how they will do. Okay, complete data you cannot go and analyze it, right, that is not our job, that is Hadoop's job. It has to analyze it and give us the data. What we will do, but we have to arrive at a solution, right, we have to know what this data is having. Normally developers what they will do, they will take a set of small set of data, okay, and they will see where their uh, data are all present. Okay, I will show it another vaccine data. Then they will go and find the logic to find out like what is the maximum temperature particular year, or what is the temperature for each year, like that they will find out. So here we have taken a raw data like this. In this 1050, no, these are all years. Okay, 1050, 1049, 1000, sorry, 1950, 1949, or this years. Okay, and this is the temperature, I think. Okay, here it is there. Yeah, this is the temperature, this is the year, and this is the temperature. This how you will know, ma'am? You can ask me the question. We will have to know it, just a moment. So once you started working on that type of data sets, then you will automatically know it, or somebody will give a hint that these are the years and these are the temperatures registered for that year. Okay, so weather data, you can also think of scenarios, okay, or the problem statements, like see, in India, in Indian weather history itself, you can take, right, in the month of, in the end of the year, there is a supposed to be cyclone in certain regions, or there is like some depression happening. If it is in the south, depressions and all used to happen, all these things. Okay, from in Chennai, there was some larger flood in 2014, sorry, 2015. And from then on, they can read like how is the weather is acting, okay, with the data. Okay, they can they can store this data using the sensors, and they can read this data. Then later on, they can predict, okay, in the month of November and December. That is how it happens nowadays. Like people will be very cautious, they will keep their all of the belongings on the top floor, so that it will not damaged by any cyclone or any depression formed in the sea region. Okay, so in the month of November and December, you can expect a kind of a cyclone will be coming. This was not done before, right? Okay, this is how they will arrive at, okay, they take the data, they will do an analysis. Okay, that's why they are giving a prediction also, like it can arrive in this month. Even we ourselves will know it, right? It can happen in this month, in this year, in the end of the year, or in the middle, whenever the rainy season starts. So you can expect that. That's how they use the weather data. Okay, so in this small set of weather data, what we will do, like the we will find the maximum temperature, or temperature, maximum temperature per year. Okay, that is what they are arriving. That is, we are going to find maximum temperature. The problem statement here is maximum temperature registered on or particular year or every year. Okay, so for that, this processing, that the data you have stored, the complete raw data you have stored in HDFS. Okay, so when you start your map task, when you start your map reduce job, right, that showed, right, we were starting a map reduce like Hadoop jar, and the jar program which we are writing wc.jar likewise. Then the input file path, that is the where the HDFS file is stored, and the output file where we want the output to be. All those things we will start. When the map reduce task is processing is started, it will divide all the this data, raw data, into input data splits. As I told, the first line, the offset of the first line will be the key. Okay, where the first line is starting, and the whole line itself is the value. Okay, this likewise, okay, the line may be ending it with 105 here. Then the next offset is the next line start, and the whole line. So this is the key value which is passed to our map task if you are going to write a map task. Okay, in my map task, I am going to write my code. Okay, my code, how I'm going to write, I will find the year and the temperature for that. Okay, what is the temperature, year comma temperature. Okay, this is going to be my map output. Okay, after I write it, so the key here is the year, and the value is going to be the temperature, which is the intermediate results, which the programmer is going to find out. The programmer is going to find out, like the temperature on each year. In 1950, the registered temperature is 0. Okay, at 1950, the again in the next uh, input split, the register temperature is 22. In the next line it is registered with 11, and in the next data you can say it is registered with 111. It is minus 11 because it is minus is there, negative is there, and 111. In the 1949 here the registered temperature is 79. So this is how our map output is going to be this way. Okay, and the intermediate output is going okay, after this is a resulted, this is where the shuffling and sorting happens. I told like this is also taken care by the framework itself. Okay, so in this is the list it will generate. Okay, in the list 1949 is the year. Okay, in the 1949 year two temperatures are registered, which is 111 comma 79. So key is this, and it contains two values, value 1 and value 2. Okay, value 1 is 111 and value 2 is 78. Likewise, in 1950 temperature, it creates a list. Okay, list with the key value 1950, and the value is 0, 22, and 11. And in your reduce code, you will be writing like find the maximum of the list. Okay, maximum in the list. Maximum in the list is 111 that it has come, and then 22 is the maximum in 1950 year. So this problem statement is you have given a weather data and they are asking to find the maximum temperature in each year. Okay, so the input splits are all happening in the framework itself, so you don't have to worry about it. But in your map task you will be writing like you will be generating a key value pair for the year and the temperature registered for each year, that is aggregated into a result. Okay, sorry, into a list, and which will give a final result as 111. So these two part only you will be writing it, other things are taken care by the framework itself. Okay, is this okay guys? So where you will be writing this code, I will show it here. We will write a code. Okay, this not with this but with another data like COVID vaccine, the total number of vaccination, like that we will find it. Okay, just a moment. uh, Okay, PWD. Where I'll show you where you can write that code. Okay, that day we have written a word counter.java program, right? In that I will show downloads. I think it is in documents. CD map reduce vi word counter.java. So here is the place we are writing our map function. For our word count program, we have divided that into tokens. Okay, and we are actually iterating to the tokens and adding one into it. Okay, that we will write it into a context. This is what it is, an intermediate place where we write our data. Okay, so in this word you will have in our, if it is a weather data program, what you will be writing it, right? Like you will have a context dot write as year comma temperature registered, temperature registered, registered. Okay, this is how you, this will give the intermediate output, right? Year and the temperature register, which is nothing but it will be giving this one 1950 0, 1950 22, all this data it will be giving it as an output. Okay, and this output, this is going to be the input to your reducer. Okay, that you will write it in this one. Then the aggregated results, what it will you will do in your, here is what it is doing a sum, right? Here you will find the greater number in the aggregator, that is maximum in the list. Right, max of that, I think there will be some code, max of the temperature registered. Okay, temperature registered. Max of the temperature registered. The key here, what you will write the output as a context dot write, as the key will be your year, and the value will be whatever the max temperature registered, whatever you are going to write it, you are going to get it, that will be your value. We will see again, if we will revisit again how all everything input is taken, how the input for this file is taken. Okay, all these things we will revisit again, don't worry. Okay, just to show like only these two parts you will concentrate, other things the framework itself will take care. Okay, this same code, this is the code, right? It is also possible, like we can write the same thing in our Linux also. Okay, Linux script we are writing. No? So you are learned a scripting language, right? Using the script also you can do that, but the scripting won't give a. It will not run parallelly, right? It will doesn't have an distributed environment and it will not run parallelly. So they have given in the book only. They have given an analogy like how you can write a Linux script for this. Okay, so Linux script is, this is going to be our input data. This is your input data. Right, this is stored in the HDFS, and they have a cat star. Okay, for the input splits, they are using some cat star function, and with that they will divide the input into key value pairs, which is nothing but the offset. Offset means start of the line. Okay, start of the line and the value, the line itself. Okay, then that they are having some script for map.rb script. Okay, that script what it will do, it will take the year and it will append it with the temperature registered likewise. Okay, then they do a salt in the script. Okay, and they will do a reduce function. Okay, they write a reduce script. In that reduce script it will find the maximum temperature from the list. Okay, this you understand now how the list is generated. The list is generated in such a way that these are shuffled and sorted. Okay, in 1949 year, and the list is created, how many temperatures are registered in that. In 1950 the list is generated, and this will go for the group, or here we are going to find the max, right? Max method, max aggregate function. It will apply the max aggregate function to this and it will give us the result. Okay, so this you can write it in a Linux script also, but we are writing the code in Java. Okay, you can also write it the same thing in Python and run it. See, the Hadoop framework is written in Java. Okay, it has some certain framework or the libraries which will help you to write the code in Python also. Okay, that's what this is. And furthermore, so another pictorial representation of how it is happening. I told, right, first it will do a input splits. Input splits is nothing but that offset and the value which I told. Okay, input split. This all happens from the HDFS data itself. Each split will have a map task. Okay, this is the task. Map task 1, map task 2. Okay, and that task will this will give the output, right? The 1950 has occurred has registered 0. 1950, say for example, it has registered 111. Okay, 1949 it has a registered 22. Can you imagine what do I mean by this? It means the input split first line is in map task 1, the input split second line is in map task 2, and the input split third line is in map task 3. That's what I mean. Okay, that's why it is giving the result in each of the map task likewise, and all this together or copied together, merged, okay, and sent it to the reduce function, which will go it as a list, okay, for each year, like 0 comma 111. For 1950 year, 49 year, it will go only here, it is 22 only, no, only one number. Then it will here in the reduce we would have written like find the maximum of the year, so it will come the output as output for the user as 111 and 1 1949 to 22. So you can imagine in real life also, like if the climate has changed and cyclone has occurred, how many times? Okay, how many times maybe the weather has a spiked, or the uh, what you can call, I don't know the weather terms, that whatever they say, no, right, whatever is the things are spiked. Okay, if it is continuously for 5 years, how many times it has occurred. Here you can also write the logic in your reduce to find how many times it has occurred, in how many years gap, or if there is no gap, then you can predict like in the next year also it will occur likewise. Okay, guys. And also the reduce function, okay, you can divide it. See, we are not talking about a very less data, the data is huge. We are talking the data is in terms of zettabytes, petabytes. You remember zettabytes, it is of a 10 power 7 bytes, I told, right? See, 10 power 7 means how many of it? It's good, and not 17 something, I think. I don't remember. Zettabytes. That much amount of data we are talking about. Okay, so we wanted to run them everything in the parallel. Okay, so sometimes it may be needed, like you will divide the data again and have a different reduce. Okay, so it means a part of the data from the mapper that will go to one reduce task, and another part will go to the another reduce task, and which will give the result. Okay, it will create two parts. You remember when I showed, right, in the output file you will have a, part file will have the output. Okay, whatever the output you are seeing, like maximum number of the maximum temperature register and all will be stored in the part file. Okay, then this, if it is a two reduced task, it needs it, the framework needs it. The number of reduced task is decided by the partitioner that I told, no, like based on the output it is getting from the map reduce, that is intermediate output it is getting, it will decide how many map tasks are needed. Sorry, reduced tasks are needed. Based on that it will divide the data and send it to different reduce tasks. Okay, so if it is two, then two outputs will be generated. Okay, that also you can see it. I will show it later on. Okay, till now, is there any confusion? Please tell me, are you able to follow it? Manigandan sir, Arul Raja, Amalan, Praveen Kumar, Prakash, Saurav, very able to follow. Little slow you want to go. Okay, you should tell me before itself, no, Amalan? Okay. What you don't understand, you can tell me. I will repeat it. Till now it is okay. Can I move on? Then we will also anyway we will see it in our code also. Okay, we will write code. In that code also we will see how it is all done. Okay, so don't need to worry about it. Anyway, till we move to pig tomorrow, not tomorrow. Monday we will see pig. Pig also will do a map reduce only internally. Okay, so it will be like you are keep on learning this concept only. It will be like that. Okay, so I told here. Okay, if again we will go to the code. Mm, okay, so while we are writing this code, no, we wrote two parts, right? One is map task, another one is the reduce task. We can say it. Okay, our map function and the reduce function we have written. or mapped method or the reduce method we have written it. Okay, then in the main is the one which is going to start the JVM. Okay, JVM is going to come to the main, and we set the configuration files on all. Here we set, okay, in this is the code from the init I told, right? Here we set the mapper class, mentioning that my tokenizer mapper is the class which I have written. Okay, so tokenizer mapper is the class. Okay, Hadoop has a mapper class. I am writing my own mapper class. This is an internal class. I told no, this is the outer class. This is the internal class. You can separately write this class also. You don't have to have it in a single file itself. Like we have written multiple Java files. No, like that also we can write. I will show one code in that. Okay, but here uh, here we have to mention that what is my mapper class. Okay, for the Java main to start, my mapper class is going to be tokenizer mapper, and I'm also mentioning the reducer class as int some reducer. And there is something like they are setting the combiner class. The combiner class, as I said, it is like between the mapper and the reducer. You don't have to write it like this. You can have this line after the here also. Don't get confused that since it is between that, I am writing in this. It is not likewise, but where this combiner functionality happens is between the mapper and the reducer. Okay, a combiner class is like a mini reducer. Before reducer does the tasks of aggregation, combiner class can help to do a optimal aggregation. Okay, like a smart aggregation, so that the workload on reducer will be reduced. Okay, that I will show how it is reduced. And it is an optional class. Okay, it is not necessary that you have to have a combiner, and it is using, it doesn't have a separate class. Not why, what do I mean by separate class means, reducer class we are writing a separate reducer class right here, like into some reducer I am writing it. And for a mapper class we are, I am writing a public static class tokenizer mapper, I am writing it. But for the combiner class, you don't have to write a separate class. Okay, it will use the class of the reducer itself. Okay, it is part of the reducer itself. Okay, and it is also called as a mini reducer, you can say it. Okay, so what the combiner class will do, what is the role of a combiner, and why you can use it or you don't have to use it, that you can we can analyze now. Now we have told that the output okay, from the first map output and the second map output, what you can think of is, um, you can think like here we are getting an output, and here say for example we are generating only two map tasks for this. Okay, it means two map tasks means we are saying like we wanted to split only it by two. Okay, okay, don't get confused. Say for example there are only two map tasks. I'll go here and write it. Two map tasks. It means you have a map one and map two. How this map and all is uh, delegated, how the tasks are created, that I will tell you. Okay, so say for example you have only two map tasks, and in that map task, this map task is generating this output. Okay, 1950 comma 0 19 for the year 1950, how many, how the temperature are registered, what are the temperature registered. Likewise it is generating, and in the map task 2, and it is again getting like 50 25 1950 15. Okay, then you can may have map task 3 also. In that you get an output for 1945. 1945 some output was there, no, like minus 11 or 1945 111. Likewise the output is generated. Okay, so the reduce function, what it will do, now we know that. Okay, here there will be a shuffling and sorting phase, and it will generate like this output. For the 1950 key, I'll write it here. For the 1950 key, it will generate the list like 0 comma 20 comma 10 25 15. Okay, and for the, it will not go here. And for the 1949, because this is a separate key, right? 1949 key, you will have minus 11 and 111. as the output. Okay, this is how it works. Then you will find the maximum in this value. Maximum of this one is 1950. You have the maximum temperature as 25, and for the 1945 the maximum temperature as 111. Okay, that is what you are going to get it. Okay, this is the list. Now what the combiner function will do, just a moment. Okay, sorry about that. I'm back. So, what the combiner function? This you understood, no? This is the basic flow. How, say, for example, if you have a three map tasks, and the first line is the first map task is going to give the intermediate output like this one, and the second map task is giving intermediate output like this one. And if you are going to the reduce, this is how we will create a list. It will create a list, and from the list we are going to find the maximum temperature, which is 1950 comma 25. But the combiner role over here is what it will do. This is the this is how the output will be. The reduce function would be called, rather than applying the, see, we are going to apply the maximum, okay, maximum aggregate function on this list, right? Rather than doing it, the if you have a combiner service going to use it, it will apply the max here itself. Okay, and find the max here itself. It means maximum of 1950 key. It will create a list here only, like a 0, 20, 10. Okay, and then here it will create a list like a 50, 25, 15. Okay, 1915 is the 50 is the key, and this is the values, key and values. From this key, here it will apply the max aggregation. I told, no, combiner is a mini reducer. So mini reducer means mini aggregation it does on the output from each map task itself. Okay, here the maximum is 1950. What is the maximum? Can you tell me? Why you people are leaving the class? I don't know. Don't leave the class. What is the max? I'm not able to find whether you are understanding or not. What is the maximum in this? Yeah, Malan, can you tell what is the maximum in this three, 0, 20, and 10? Yeah, 20. So what is the maximum in this one? It is a 1950, 25. Okay, then these two will go for the reduce aggregation, which is nothing but 1950, 20 comma 25 list is a generator. Okay, then it will give the maximum in this year. Okay, 1950 comma 25. Okay, can you see what the reducer is doing? I will take a slide. Okay, I told, like, say for we will work on from the intermediate result, because we don't have to worry about splits. Pass out the least value, maximum value or the least value. That is fine. That's right, sir. So what was happening before? Say for example, I have 0 from one map task value, 20, 25, like this. This is the output from one map task. Okay, one map task one. And if I have an output from 1950, 50 and 1950 in the year, same year, 55. This is a map task 2. Why it is creating with getting for the same year two sets of output? Two sets of output we are getting. Why? Because the first set of inputs split. Data has gone to map 1. The another input split has gone to map 2. That's why we are going to get two sets. What was if we don't have a combiner, what this will do, it will shuffle and sort like this: 1950, and it will create a list like 20, 25, 50, 55. Okay, this is the intermediate result before going to the reduce function. Once it gone to the reduce, what it will do, we will apply a max on this data, right, on this values. Maximum will find, will do a compare. How max will compare? It will compare with 0 to 20. It is not higher, 20 is higher, 20 to 25. Likewise it will compare and give us the result as 1950 comma 55 is the highest temperature registered. Okay, highest temperature registered. This is what a normal map task do. With the combiner, we will see how it is optimal. Okay, what combiner will do, I told, like if I have a combiner service to be used, what it will do, the same set of output, 1950, 20 and 1950, 25. Okay, this is from map 1, and from the map 2 it is and same 1950, 50, 1950, 55. Okay, so this will have a intermediate out list like a 0, 20, 25. For the key 1950, you have this input, and for same year 1950, you have another list 50, 55. Right. So when you have a combiner, it will apply the max itself in this data. Okay. So 1950 comma 25 is the maximum in the map reduce task 1, and 1950 55 is the maximum. Okay, next it will go to the our reduce method, which will again have in our reduce we will have a 1950, and the list is nothing but 25 comma 55. Okay, this is the output, right? Now it will, if we apply the max method on this, it is going to find the max only on two numbers, two, because we are not going to apply the max on five numbers, right? Five temperature we are not going to apply, we are going to apply the maximum function on the two numbers. Can you see the difference now, how it is optimal? Rather than applying the map function on five temperatures register, rather than reducing it here itself, here also the map function is applied on three numbers, and it is applied on two numbers. So we are reducing the functionality or the processing which is done by the reduce task by using a mini reducer. Okay, so this is like an optimal solution. They can also ask like, in order to reduce the overhead of the reducer task, what you can do, it you can have a combiner will reduce it further on, and it will give a consolidated output to this one. Okay, consolidated means aggregated output, and again you can apply whatever the function on a simple set of data. You can imagine, right, this is a large set, and it will not be like this small amount of data, right? It is going to be huge set. In this way, if you use a combiner, then it will give the processing time also will be reduced. You can imagine, no, like a max running a max function on five data. This is five number of inputs, can be 100 number of temperatures also. Okay, the number of temperatures registered may be 100 numbers. So applying max on 100 numbers, then applying the on the divided data will be more efficient, right? That's what we are doing here, dividing and processing, parallel processing, right? So this is more efficient. So combiner can be used in this type of to get an optimal results or the aggregated results or efficiency. To increase the efficiency of the reducer, you go for that. and it is optional. It doesn't have a class. You don't have to write a class about that. You can just use the class of the reducer. What does it mean, class of the reducer? Whatever we are asking the reducer to do, it will do it before aggregating the data. Okay, before merging the data. Okay, we saw a phase, right? After shuffling and after sorting, there is a merge phase in the before going to the reduce. Before merging the data, here itself the combiner will do whatever we are telling the reducer to do on a small set of data. Okay, that you can merge it together and get the total output. Uh, are you able to understand this one, the functionality of a combiner? Okay, so if you can see it here, with the combiner function, this is how the output will be. The reduce function would be called with only. Okay, the reduce function will be called with only 20 and 25. Now here you will get the output as a 20. Here you will get the output as 25. It will work on 20 and 25 only two registered data. Okay, technically we can express the function calls on temperature in this case as follows. It means, see how they are mentioning is like 0 20. The first set it we have applied a max function, and on second set we have applied a max function, and it is, and together we are going to apply the max function. How it is optimal? Because on after the map task itself, you will apply this data into a smaller set. Okay, so the map function is applied onto a smaller set, not to the complete set, which will obviously take time, right? Traversing 100 input datas and finding the max from 100 input means it is going to take time. Then if we divide it into 50-50 means it is easy, right? Or whatever the 50-20, 75-25, likewise we cannot divide it likewise, but rather than what we are doing, we are going to apply that combiner on the each output of the map task itself. Okay, is this okay guys? Are you able to follow it? Okay, sorry, something came. Combiner, what it will do, it's fine, right? Is it okay? Push out the least value or push out the maximum value, anything is fine, sir. So there is a con. Okay, it depends on when you have to use the combiner. Okay, you cannot apply it on everything. Right, that's what the cons or the disadvantages. Like if you're going to find the mean, okay, mean of the temperature, then you cannot apply the combiner. Okay, why? Because we have taken 1950 year temperature as in one set as a 0, 20 and 10, right? In the another list as another from the another map task as 25 and 15, right? See, that's what they're saying. If you are going to apply the mean for 0, 20, the whole set will be different. Okay, the mean for this is 14. Okay, if you're going to apply, find the mean of all the temperature, it is going to be 14. If you apply mean separately, mean on this and the mean on mean, find the mean value of this temperature and find the mean value of these temperatures and find the total mean, complete mean, the output is a different. Okay, so you should be thinking while using the combiner function. If you apply mean and all, it will not give proper the result. That's the reason you have to see maximum minimum, it will give the proper result because that is easy. But if you're trying to apply mean, this mean will be different, no? 20 plus this will be 20, I think, by 2, something like that. Okay, plus by 2 only, right? That is a mean. That time you have to think and use when you can go for the combiner, when you cannot go for the combine. Statistical function output, if you are going to get it, that time you have to think it. Probability output like that and all, you have to think and use it. Okay, is this okay, guys? Is it confusing? Okay, others. Harul Raja, is it okay? Okay. Okay, can I move forward to the again same thing? We will read through that. how it is happening with the input file. From for exam perspective, what sort of question we can expect? The question is like, you can give a, we will you will be given a data set, and from the data set you can will have a problem statement asking you to write a map reduce program to find, say, the number of here no the temperature, uh, maximum temperature per year likewise, or else if some other input data means one data set we will work on with the vaccination data. Find the total number of vaccinated, states will be there, and you can find the total number of vaccinated in each state likewise. Or you can find who has they which vaccine they have administered, like Covishield or Covaxin likewise. Or some other data, bank data you can take, like the number of customers uh, who had opened an account on a particular period likewise. The complete data set will be given. You have to write a map and reduce. Every time you will write only two, but you will understand the flow. Okay, if somebody asks you, you should know like how it works, because internally it will start the map reduce only. Okay, so this is the overall for the count, word count. In this the input is, say for example, this you can think of from a text file, like, okay, this I have taken from some internet only mm, for a better understanding. Okay, deer deer, river, car, each one is a single line you can think. Okay, the split happens for the each line. Okay, each line it is happening, and the key for the split will be like, as I told here, it is not written. First line is starting with zero offset. Okay, and the complete line itself zero comma. Okay, and this key value will be, you can count this. Okay, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. It ends with 15 characters. It is going to start from 16. Okay, so 16 is the offset for the second line. Likewise, 17, 18, space also should be counted. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. It is ending with 28, and it will start. The next line is going to start from 29. Okay, this is the offset. This is the input split. Okay, and this goes to the, see, each line is starting a one map task. Okay, each line will start a one map task. Okay, so this line, it is giving the output intermediate result, that is the mapping output as there has occurred once, bear has occurred once, and river has once. Even if it has another word like deer, okay, then again we will write deer has occurred once. Okay, this is the intermediate result. You can see it in the second line. Car has occurred once. Here we are not doing aggregation. Okay, please remember it. We are not doing aggregation here. We directly say whatever the number occurred. Okay, car has occurred once, car once, car once. So here car, river, deer, bear, and all are key, and one is the value here. Okay, it will change. This is a word count, so we are writing the code likewise. But for the year, we have seen it differently, right? The key value for the year and temperature we have given as year as the key value, key, and the value as the temperature, right? Key value temperature. This is the value. So it will change according to your program, according to your data set, or what output you wanted to get it. Then here it happens the shuffling. Okay, so what it does, it took from the all the map task beer. Okay, the key b, beer, and it has added one to that. Okay, then all cars it has taken from all the map tasks, and it has added as a list. Okay, 1 comma 1, how many times bear has occurred? Bear once, bear once. So this is the list. Car has occurred three times, 3 1 comma 1 comma 1. Okay, this is a list. You can see it here. List of values it will generate. And deer has occurred once. And river has occurred in the complete set two times, 1 comma 1. So in the reducing phase we will do the sum. Okay, sum method we will use and do the sum. So bear sum of the list. Okay, so bear has 1 plus 1 2, car is 3, and deer is 3, river is 2. Okay, and final output is key comma value pair. Everything together it will be stored in the HDFS. Okay, that is the storage unit. It is a read from HDFS only. Okay, read and return. So in our code, this context write we will do, right? Context dot write. This will actually write into the HDFS. Intermediately here also, after the map, we are writing the key value into context text. Context dot write. Right, the intermediate after the mapping also we will write that key value as key comma 1 we will write no ONE. That also we will write it into the HDFS, but this will not, it will be an intermediate result. Okay, this will not get stored permanently in the HDFS. Only the final output which will be stored in the part file, part hyphen or hyphen some 000. Okay, this is a reduced file that only will be stored in the HDFS. The context right which we do in the intermediate after the mapping, if you see in the code, after we write no this one, after the mapper class, the map method, we write this context right. No, this will not be stored, this will be stored in a temporary file. Okay, not permanently into HDFS. In the temporary file of HDFS only it will be stored. Okay, why? Because a reducer has to read the input and it has to process it. For that reason it will be stored in the HDFS only. Okay, this is what we are seeing. Shift F5. Okay, then furthermore, okay, this this flow is fine, right? Now you will be able to easily understand. So this is the part the programmer will write. Even in your Python code also you will write it with this only, and you can write this or this part, this aggregation, no, sorry, not after this to this we will write it in a reduce function. Other things are taken care by the framework. Okay guys. Okay, so what all the other thing, the computation logic, how it happens is, say we told, right, like this is the original data set. Maybe you can think this as a raw set, raw data. Okay, and while this data, this is only three lines. Say you think of like 3,000 lines, and you can how it is stored while storing into HDFS itself. This 3,000 lines will be divided and stored. Okay, will be divided into chunks of 128 megabytes. 128 megabytes is quite huge only. Okay, that it will be 128 megabytes, it will be divided. And say for example, if you think of this thing, okay, this one I taken it from Edureka only, you can go and see the uh, 3,000 lines. It will shall maybe divided into three parts, maybe thinking that it is of 128 bytes. Okay, maybe stored in slave 1, the first 1,000 bytes, second 1,000 bytes in slave 3, and the third, sorry, slave E, and third 1,000 bytes in slave C. Okay, so we write this Java code, right? We write a word count dot Java. We write a Java code, and we are creating a jar file, right? wc.jar something. This processing actually happens in the slave node itself. Okay, so when we start the map task, map that command we will write, right, like Hadoop jar word count map, that what it will do, it will transfer this jar file into where the data is present. Okay, so here you will have this processing logic, wc.jar, wc.jar, and wc.jar. Okay, that's what the difference, what they are saying is, in the traditional approach, that's what without map reduce and all, without distributed logic, what they will do, all the data will be taken to the particular master machine or particular some other node. Okay, here the processing logic wc.jar, this is the code, right, that will be present in a single machine. On all data, if it is present in different machines, will be taken here. Whereas in the MapReduce approach in Hadoop, the processing logic will be moved to the where the data is present. Okay, data is not less, right? You can imagine like zettabytes of data or petabytes of data bringing into a single machine and working on it is will be take so much time, huge amount of time. And if you send the logic, this will run parallelly, this will run parallelly, right? And you can aggregate the results together. That framework itself is giving aggregation of the results, and you can store it in the again the hdfs directly. If you're storing it into slave E, it gets duplicated, right, in slave A or slave C. Okay, so this internally storing and all these things taken care by the framework itself. So the one thing, one logic, how it is happening is the logic is moved to the business logic, or the computation logic is moved to the nodes where the data is present, rather than the data which is moved to the centralized area. Okay, one more thing I will tell you how it is actually happening. I don't have the slides. Maybe I will try to put that somewhere. I have seen that. Okay, so how it will all happen originally is the client I say I am writing a map reduce job. Okay, map reduce function, right? Map reduce is also a client because I am the client. I am saying like I wanted to find the maximum temperature. Okay, for that I have written for the particular year, for years, all the years, maximum temperature for all years. So I am the client. I have written a map reduce code, that is a Java code. Okay, I have written compressed and given a jar program. While I submit the program, like while I start the map reduce job, okay, like Hadoop, I will give the jar file name. I'll start input file where my hdfs file is present, and where my output file has to go. Everything I mention it, it means I am submitting a map reduce job, okay, as a client. That it will go to the resource manager. So there are two things I told, no, resource manager and node manager. Resource manager is a part of the yarn. Yarn takes care of resourcing, and there is also like application manager. Okay, a resource manager and application manager all belongs to yarn. It takes care of allocating the resources means the cpu resource. Okay, cpu time and memory resources. Okay, how much memory this process has to needs to run, okay, on the data likewise. And the application manager, there is also an application manager running, which will give, which will keep track of the applications. See, MapReduce, I am as a client, I am giving a MapReduce job, and some other client. It in Hadoop infrastructure, no, you would have seen that architecture, right? If you see the architecture on the underlying HDFS, you can see that MR, Pig, all these applications can be running. It can run parallelly also. Okay, some programmer can use it, means you have a data set. Okay, a large data set, or you can imagine like a data set of stock market data set is keep on is present in here. Okay, that is a live data set, right? So somebody is writing program in MapReduce to analyze the stock market, and somebody is writing pig scripts, okay, to analyze in the stock market, and somebody is connected through Hive. Okay, so these are the applications are running. It is possible, it will work like this only. Okay, you will have a hdfs on which you can have many applications. So this application manager will keep track of who are the applications connected, and also it will provide an application id, okay, to each of the applications, okay, in order to identify it. Okay, once I submit a map reduce job, what it will do, the nodes data are present in nodes. Maybe I will take that pictorial representation. Okay, maybe next class I will put, now I don't have it. Okay, say for example this is a data node 1, data node 2, data node 3, data node 4, and in this there is a something like an application master running. Say for example in some of the data nodes it is running. It will find out, say, the data, that split data, the temperature split data is present, like the first input splits I told, no, say that line is present here. Okay, 55, that offset is present here, and in 100th offset is present here. Okay, So it is present in data node 1. Say for example, if it is present in data node 2, once you submit the application, the yarn will contact the application master. Okay, the application master will know where this data is residing. Okay, and here and in each of the node, okay, there is a node manager running. See, these are the processes you will be seeing while you are running the Hadoop. Okay, uh, the processes which are nothing but a name node process you will see, data node process you will see, yarn processes which are nothing but the resource manager and the node manager you will see, and what else is a secondary name node. Right, secondary name node will do only the merging of the FS image and the edit logs. Okay, so resource manager is only the yarn processes that will have the application master running. Likewise, the node managers, see we have two slaves, right? Slave 1 and slave 2. So in the slave 1 and slave 2, the node managers will be running. Okay, that will take care of the about the node status, and it will send the to the name node the heartbeat. Okay, whether the node is alive or not, heartbeat, all those things will be taken care by the node manager. Okay, once you submit a job, it takes the application manager starts the application master. Okay, in one of the nodes it will be present, and that will delegate your processing to the data where it is present. Okay, and it will do all the map reduce jobs, and it give the aggregated results, and it will store back into the hdfs itself. This is how the flow will be normally. Okay, this pictorial I will try to get it. This I wanted to tell. Maybe they will ask you what are the processes internally running for a yarn. It will have a resource manager and the application manager. Okay, and node manager is mostly will be running in your nodes. If you set up that multi-node cluster, you can see this. You can if you format a name node node itself, this two processes will be running in slave. And you can also see, I'll show it in the next class because my the multi-cluster didn't come. In that, if you store any data in your master or in one of the slaves, it gets replicated in the, because we have given the replication factor as 2 or 3, right? The data will get automatically replicated in other nodes also. This replication of a particular file, right, that also we can set it, that I will show it in the next class. Okay, so this is all about map reduce in depth, and we will see the remaining of input formats. Here the slide is there. No, this doesn't have this. That we will see in the next class. Okay, till now is it fine, guys? How it is all happening? Amalan, Manigandan sir, Nishant, Prakash, Saurav. Others, you can go through that book also. The first chapter itself will contain most of the information. Okay, in depth overall information in that. It will be interesting. In depth, then you can go to each of the chapters. Maybe for the first level of understanding, that first chapter itself will be good in the a definitive guidebook. Okay, later on you can work on that. And if you give me 5, okay, we will see in the next class. Okay, like I will show you how the data are read in this. Okay, and we will also configure in our eclipse. Okay, in our eclipse, no need to write in your terminal your code. Okay, in eclipse itself you can write your map reduce program, that I and because we need libraries. right? That how to set it. We can create the jar files itself and then start the map reduce. That I will show you in the next class. After seeing the input formats, we will work on two data sets, and you can take one assignment. Then it will be very, you will be well accustomed with the map reduce in Java. Okay. There is a program in Python also. I'll try to run it and show that. Okay. Otherwise in Java this is way. Okay. We'll see in the next class. Okay. For the more any doubts you can ask me. Otherwise you can leave. Keep your machine ready because in your exam you have to run and show. That's why. Run and show means you will show the output. Okay, so if you can communicate with the other class members, please ask them to join the class, or I'll at least find out why they are